Okay, so now we're going to cover how to do some optimization, how to get good quality EFTEM images on the microscope. So we're looking at back at the same region we keep looking at, and I'm back in the EFTEM map technique. So I'm just going to go ahead and acquire a 3-window nitrogen map. So I'm going to stick with a fixed exposure time of 20 seconds, binning 4, and the default window positions for nitrogen. So I'm going to go ahead and capture that map. Okay, so you can see straight away that our post-edge image is very, very, very out of focus. So we could take the reasonable assumption that our map is going to be equally blurry. But let's see how that goes. Accept all of these. Accept. Okay, so we've ended up with a pretty terrible map. It's really poor signal to noise ratio and very blurry. So remember from the lecture the importance of chromatic aberration in EFTEM. So right now there's no objective aperture inserted. So beta, the collection angle, is huge. And remember how beta limits the chromatic aberration. So it's really important that we use an objective aperture. So I'm going to put in an objective aperture, our favorite 60 micron objective aperture. And then we'll go ahead and acquire the same map again. So same parameters, so 20 seconds. The only difference here is that we've added the objective aperture. So there we go. Except, as I said, we're going to cover the drift correction in detail in the lab with some examples that you can play with on your computers. So accept. So okay, so we see some improvement, but not really enough for us to be happy with that. So remember, there's in addition to the effect, chromatic aberration, we also need to refocus. So the focus, the objective focus for the inelastic scattering electrons is very, very different from the elastic scattered electrons. And that's due to aberrations in the microscope optics. The lenses are not really designed to or optimized for focusing anything other than 0 EV electrons. So let's go to our live image, and we need to go and look at kind of a filtered image at energy loss and do some focusing. So we need to have the slit in, the slit's inserted, and I'm going to go to 400 EV. So we don't need to go to the exact energy loss that we are mapping for our experiment. We just need to go to something that's a few hundred EV and use a slit width that's maybe like 50 to 100 EV wide. Okay, so there's no real usable contrast in that image. And I'm going to increase the view time now. You can see I can get up to kind of now 1.36 seconds. But the contrast still, kind of the signal in that image still isn't very, very interpretable. It's not really very useful. So this is where the LD mode comes in super handy. So the HDR mode is using what we call rolling shutter, which are covered in the lesson. So it's frame summing. So we're always running at maximum frame rate, 10.6 millisecond kind of frames, and we're summing them. But the problem is when we have very kind of weak intensity on noisy kind of frames, then we're just summing lots of noise, and we don't kind of really help ourselves for this kind of imaging condition. So I'm going to go back down to a fast exposure or single exposure, and then I'm going to switch to LD mode. So LD is going to integrate for the full kind of the view exposure time here. So now if I go up to something like 0.678 seconds, whoops, I didn't change it to LD mode. So let's go switch off the view, go to LD, and try again. Okay, so you can see now as I increase that view time, then we kind of get to a situation where we have usable contrast in the image. So I'm going to use the objective lens and refocus. So that, remember, this is incoherent scattering, like inelastic scattering. So we focus this and we're really looking for maximum contrast. So I'm going to go with something around there. And then go ahead and capture the same map again. So bidding 4, 20 seconds, nitrogen, capture. Nearly there. And hey presto. Drift measurements and accept. Accept. There we go. Okay, so that's our final map. So I'm going to bring the other two onto the same workspace. So multi-map 21, move to workspace, multi-map 21 and 20. So that's move to workspace, multi-map 21. So this is kind of our trend, I believe. Yeah, right. So this guy is no aperture, no refocus. So terrible. And this one is aperture, no refocus. So less terrible, but still nearly, not nearly good enough for us to do anything with. And then on the far right here, this is the aperture in and refocus. So you see how important it is to do this in EFTEM. It's really fundamental. It makes a difference between you having good maps, good data, and not. So always remember these steps, and yeah, perfect.